In this lesson, we're going to find the radius of a circle that is perfectly inscribed inside a trapezoid. And you'll see that a few simple geometry properties lead us all the way to the answer. So stay with me until the end because everything fits together beautifully. And if you enjoy learning math this way, don't forget to like this video, subscribe to the channel, and leave a comment with your answer before we finish. Let's begin by carefully reading the given information. We have a trapezoid where the top side MN is 12 units and the bottom side PQ is 18 units. A circle touches all four sides of the trapezoid, so it is tangent to every side. The center of the circle is point C and we are asked to find its radius, which we'll call ER. Now suppose the circle touches the top side at point T and the bottom side at point U. The first property we use is that a radius drawn to a point of tangency is always perpendicular to the tangent line. That means CT is a radius, so CT equals R, and CU is also a radius, so CU equals R as well. Now let's look carefully at the quadrilateral formed by the left side of the trapezoid together with these two radii. This shape is a rectangle because the radii are perpendicular to the parallel sides of the trapezoid. In a rectangle, opposite sides are equal. So the horizontal distance from the left side to point T is also equal to the radius. Therefore, MT equals R, and similarly, PU also equals R. Now let's use the lengths of the parallel sides. The entire top side MN is 12 units. Since MT equals R, the remaining part TN must be the whole length minus the radius. So TN equals 12 minus R. In exactly the same way, the entire bottom side PQ is 18 units. And since PU equals R, the remaining segment UQ equals 18 minus R. Now let's use another very important theorem. Tangent segments drawn from the same external point to a circle are always equal in length. This is one of the most useful properties of tangents. So, if the slanted side touches a circle at point V, then from point N, the two tangent segments NT and NV are equal. Since Tn equals 12 minus R, we immediately get NV equals 12 minus R. Likewise, from point Q, the tangent segments QU and QV are equal. Since UQ equals 18 minus R, we have QV equals 18 minus R. Now, the entire slanted side NQ is made up of the two pieces, NV and VQ. So, NQ equals NV plus VQ. Substituting the expressions we just found gives NQ equals the quantity 12 minus R plus the quantity 18 minus R. Combining like terms, 12 plus 18 gives 30, and negative R minus R gives negative 2R. Therefore, Q equals 30 minus 2R. Next, drop a perpendicular from point N to the bottom side and let it meet the bottom side at point W. Since the top base is 12 units and the bottom base is 18 units, the extra horizontal distance is simply 18 minus 12, which equals 6. Therefore, WQ equals 6 units. Now notice another important fact. Because the circle touches both the top and bottom sides, the distance between those two parallel sides is exactly the diameter of the circle. The diameter is twice the radius, so NW equals 2R. Now we have a right triangle, triangle NWQ, and this is the perfect time to apply the Pythagorean Theorem. The theorem tells us that the square of the hypotenuse equals the sum of the squares of the other two sides. Therefore, NQ squared equals NW squared plus WQ squared. Now substitute the expressions we already know. This gives the quantity 30 minus 2, 2r all squared equals the quantity 2r all squared plus 6 squared. Let's expand both sides carefully. The quantity 30 minus 2r all squared becomes 900 minus 120r plus 4r squared. On the right side, the quantity 2r all squared becomes 4r squared, and 6 squared equals 36. So our equation becomes 900 minus 120r plus 4r squared equals 4r squared plus 36. Now pay close attention to this simplification. The 4r squared term appears on both sides of the equation, so we subtract 4r squared from each side and those terms cancel completely. That leaves us with 900 minus 120r equals 36. Next, subtract 36 from 900, giving 864. So we now have 864 equals 120r. Finally, divide both sides by 120 to isolate r. This gives r equals 864 divided by 120, which equals 7.2. Therefore, the radius of the circle is 7.2 units. I hope this problem helped you see how tangent properties, rectangles, and the Pythagorean theorem work together in one elegant solution. If you found this explanation helpful, be sure to like the video, subscribe for more geometry lessons, and let me know in the comments what type of math problem you'd like to solve next.